Carbon nanotubes are a fantastic material. Light, strong, small, highly conductive and versatile, they're finding uses in everything from lightweight composites to high-performance batteries and touchscreens to drug delivery systems. But how safe are they? Research is increasingly showing that the wrong carbon nanotubes in the wrong place are potentially bad news for your health. The trouble is, this isn't much help without knowing what a wrong carbon nanotube looks like and what the wrong places are. The trouble is, carbon nanotubes are not just carbon nanotubes. They might be short, long, thin, fat, straight, curvy, tangled, spiderweb-like, bunched up in a tight ball, single-walled, multi-walled, big clumps, small clumps, or almost any combination of the above. And the risks they present depend critically on what type of carbon nanotube you're looking at. A very long, thin, straight, multi-walled carbon nanotube, for instance, is a completely different beast to a spiderweb-like cluster of single-walled carbon nanotubes. On top of this, chemistry matters. It's easy to think carbon nanotubes are just carbon, so what? But in addition to the supreme importance of how those carbon atoms are arranged in the material, carbon nanotubes often come with additional chemical passengers. These might be metal nanoparticles used in their production, or chemicals added to their surface to make them easier to work with, or even drug molecules inserted into their core to create more effective therapeutics. In all cases, the specific chemistry of a given carbon nanotube is rather important. Then there's the question of where the carbon nanotubes are used and how they are used. It's easy to imagine how someone might breathe in carbon nanotubes while handling them as a powder. Harder if that powder has been suspended in a liquid or formed into hard pellets, though. And once the nanotubes have been used in a product like a battery electrode or a carbon composite bicycle frame, it's much more difficult to understand how a significant exposure might occur, especially as this material is often used in extremely small quantities. And because of their size, shape and chemistry, you need to work really hard at pulling carbon nanotubes out of a product once they're in it. And when you do, they don't often look the same as the material that went in, which means that research on the toxicity of freshly generated carbon nanotubes may not tell us what we need to know about the hazards of those that are released from products. The bottom line is that not all carbon nanotubes are created equal, and any residue of risk equity that might exist is further eroded by how they are used, which leaves us with a rather large challenge. As we learn more about what makes carbon nanotubes toxic, what do we need to do to understand more about who is likely to be exposed to what, and how exposures can be reduced to acceptably safe levels? Because without this, the responsible development and use of carbon nanotubes is going to be tricky, to say the least. For more information on carbon nanotubes, check out the links below, and stay safe.